Here's our review. So we have to remember a squared plus b squared equals c squared when we're looking for a missing side of a right triangle. So we always label a, b, and c, and we write a squared plus b squared equals c squared. Okay. 7 squared is 49 plus, not yet, 49 plus x squared equals 25 squared is 625. Make a little thinner here. We have to get rid of the 49. X squared equals 576. We want to do a square root of both sides to get rid of the square. Alright. Squeezes. Come on. So we do the factor tree. We get 288. Oh my gosh. Oh my gosh. Sorry about that. This board is whack. Goodness gracious. Oh my gosh. Alright, so 2 times 288. And if it ever wants to write, oh my gosh, it's 2 times 144. Without, oh my gosh. My apologies, the board will literally not do what I tell it to do, which is awesome. So, 2 times 144, 2 times 72, 2 times 36, 2 times 18. Whoever wants to write, okay, 2 times 9, and then 9 is 3 times 3. Now that's a lot of prime factorization. And how many pairs do we have? Pair of 2, pair of 2, pair of 2, pair of 3. Since there's no loners, we're going to do 2 times 2 times 2 times 3, which gives us 24. Alright. Over here, we got a right triangle, and we know A, B, and C. So we will do a squared plus b squared equals c squared. A 100 plus 25 equals x squared. So 125 equals x squared. And so to get rid of that square, we square root both sides. Square root of 125 is 5 times 25. And then 25 is 5 times 5. Now we have one pair of 5 and one loner 5. So that is 5 square root 5. Okay. Down here, we got, A, B, and C. So 5 squared plus 12 squared equals c squared. Now, if you remember your Pythagorean triples, 5, 12, 13 is a Pythagorean triple. But if you write this out, you get 169 equals c squared. And if you do the factor tree of 169, you get 13 and 13, which is just 13. Okay, over here, 7, 9, and c. Got A, B, and C. So 7 squared plus 9 squared equals c squared. 49 plus 81 equals c squared. We got 130 equals c squared. And then square root both sides. 2 times 65. 5 times 13. Do you see how there's no pairs, only loners? So the square root of 130 is the answer. number 5. Now this is similar to the word problem, and we're doing this in decimal form, so we're not going to use a factor tree. So I have my A, B, and C. So 5 squared plus h squared equals 10 squared. That gives me 25 plus h squared equals 100. Subtract 25 from both sides. H squared equals 75. And when you square root both sides, square root of 75 does give you a decimal. 8.66 meters are my units of measure. Please be careful with this one. There's going to be one like this on your test. Okay. Once again, you got A, B, and C. We'll call it X. Okay. And, we're still doing this in decimal form, so we can do A squared plus B squared equals C squared. What's 12 squared plus 16 squared? 400 equals X squared. Square root both sides. Okay, so 20 equals X. 20 what? Feet. But 20 feet is not the answer. Can I please get you to see this? How tall was the pole before it broke? Remember, the pole is this plus this. This was the whole pole. You have to add them together. Add the missing side to the 12 feet. So take this 12 plus this 20. So the pole equals the 12 on the bottom plus the 20 on the top, and that gives you 32 feet. Do not get caught putting this. This is not the answer. Not answer. Alright, careful. Okay, all of these are starting from the letter F. So from F, here's my O. Across from 90 is my H and my A. Okay, we got SOHCAHTOA over here. So let's talk about sine. Opposite over hypotenuse. So the 4 over 5 doesn't reduce. Cosine over here is adjacent over hypotenuse. So 3 over 5 does not reduce. And the tangent, O over A, that's 4 over 3, does not reduce. Don't put it as a mixed number. That'll do. Okay? On these, let's do some trig. Make sure your calculator's in degree mode when you're doing these. Okay? From here, I got O, H, and A. You don't need H because nothing's there. So OA is TOA. Okay? Tangent 50 equals O over A. When X is on the bottom, we switch the trig. So X goes to the left, 17 stays on top, tan 50 goes to the bottom. 17 divided by tan 50 is 14.26. Okay, units, whatever that is. Okay, so let's label O, H, and A. I don't need A, there's nothing there, so OH is so. For sine, sine 35 equals O over H. When X is on top, to get rid of the divided by 26, I do times 26 times 26. Cancels out over here. Sine 35 times 26. Sine 35 times 26. 14.901. Okay. So here's my angle. Got label O, H, and A. Now this one, I have no O, So that's ka. AH is ka. So cosine 53 equals A over H, 45 over K. And when your variable's on the bottom, you switcheroo. So K is on the left, 45 stays on top. Cosine 53 is on the bottom. So let's do that. Cosine 45 over cosine 53. 74.77. Okay. Over here, for my angle, I got O. Here's my 90. Got my H and my A. O has nothing, so AH is ka. Cosine 60 equals A over H. X over 13. Now, X can't be over 13, so we do times 13. Cancels out. Times 13. Cosine 60 times 13. And I get 6.5 units. In this case, it's centimeters. Alright, at the bottom here. Now, in this case, like it says, we're going to replace question marks with X. So this is my X angle, my X angle, my X angle. Once again, when we're missing an angle, we're going to be using inverse trig. Okay, so label O, H, and A. I don't need H, so let's not forget. So, ka, toa. Alright, so OA is toa, so tan X equals O over A. I can move the trig to the other side and it becomes inverse. So X equals tan inverse 21 over 25. What is tan inverse 21 over 25? 40.03. And since we're talking about a missing angle, that's in degrees. Same thing here. We've got label O, H, A. This time I don't need H. So OA is toa. Tan X equals O over A, 9 over 29. So again, tan goes to the other side, but it becomes inverse. So X equals tan inverse 9 over 29. $17.24, and that's in degrees. Last but not least, we label O, H, and A. This time I don't need O. AH is ka, so for cosine, X equals A over H, 37 over 40. Bring the trig over, it'll become inverse. X equals cosine inverse 37 over 40. Oops. 22.33 degrees. Alright. Next one. So they're asking what is the angle the sun hits the flagpole. Okay, so what is this angle? We'll call it X. Okay, so label O, H. Oh no, actually, wrong. X is already there. Here's my X, right? From here, we're going to label O, H, and A. We don't need H. Okay. Again, so toa is super important. So OA is toa. So tan X equals O over A. We just do like two of these, didn't we? Move the tan over, it becomes inverse. So X equals tan inverse 42 over 25. So we get 59.24 degrees. Now these three, just type it in the calculator. Okay, make sure degree mode. Cosine 91, easy. Cosine 91. Negative 0.02. We're going to round it 2 decimal places. Okay, sine 24. 0.41. Tan 17. 0.31. So again, make sure you round to 2 decimal places. Do your best. Now, on these you want to be really good at doing vector trees, okay? So 2 does not go into 147, but 3 does. Here, check it out. 147 divided by 3. Boom, it's 49. So 349. Hopefully you know 49 is a square of 7 and 7. Pair, 1 dies. So 7 goes out. Loner stays in. Now it's done. When there's a coefficient, circle it. It's like a pair that's already outside. Okay? Go thinner here. Okay, 60 is 2 times 30. 30 is 2 times 15. 15 is 3 times 5. Do I have any pairs in the tree down here? Pair of 2, crossing out. Okay, so I have a coefficient 3, loner 2, pair 2, the 3 and the 2 multiply to make 6. And on the inside, the 3 and the 5 loner multiply to make 15. Okay? On the next one, you can only subtract the same square root. 8 minus 5 is 3. The square root stays the same. Alright? When you're dividing, oh my gosh. When you're dividing, 2 over 1 is still 2. And then 12 over 4 is 3. Divide the coefficients, divide the square roots. If you only have a square root on the bottom, remember you multiply by the same square root on the bottom and the top. 6 times square root of 3 is 6 square root of 3. On the bottom, square root of 3 times square root of 3 is just 3. And that equals 6 divided by 3 is 2. Don't forget to reduce those coefficients, okay? Everyone gets messed up on this. Square root of 7 and square root of 7 are the only ones that can add. 8 plus 11 is 19. The square root stays the same. The different square root comes down next to it. Plus 4 square root of 5. Okay, you can only combine like terms. Okay, you got to remember special right triangles. So 9 is across from 30. Let's put a little 9 here. And that means this is 60, right? Well, if x equals 9, then 2x, let me say x squared of 3, replace this x with a 9, you get 9 squared of 3. 2 times 3, 2 times 9 is 18, so there you go, 18. Back that up real quick. 9. There you go. Showing some work. Alright, if it's isosceles, we know that these angles are the same, and it's a 45, 45, 90 triangle. So if across from 90 is 24, across from 90, 24, this is the tricky one. We've got to set that equal and solve. X squared of 2 equals 24. To get rid of that square root of 2, we divide by the square root of 2. Can't have a square root on the bottom, so we times it by the square root of 2 on the bottom and the top. The top gives us 24 square root of 2. The bottom gives us square root of 2 times square root of 2 is just 2. And remember, 24 over 2 reduces to 12. Square root of 2 stays there. So that's my x value. So that means this is 12 square root of 2 for x, and this one's 12 square root of 2 for x. Alright? Down here. Okay, that's 45 and 90, that's 45. We got a 45, 45, 90. Across from 45 is 7, so x equals 7. So 7 square root of 2 is going to be 7 square root of 2. You just throw a little square root of 2 at the end for the hypotenuse. 30, 60, 90, last but not least. Okay, if across from 60 is 7 square root of 3, 60, so 7, 7 squared of 3. We'll set those equal and solve here. So if x squared of 3 equals 7 squared of 3, when I try to get rid of the square root of 3 by dividing, it's going to cancel out on both sides. So guess what? X equals 7. X equals 7. And then 2x, 2 times 7, 14. Cool.